Hello, today we're going to take a look at some unit conversions. And so to start, I want you to think about this rectangle. Think back to geometry. The perimeter of this rectangle is 48 feet. What is the perimeter in yards? Oftentimes in math, we're asked for an answer in units that may not necessarily be given by the diagram. So it's really important to understand how units are converted and how they're related and how we can convert from one thing to another. So our lesson for today is going to involve unit analysis and conversion. You're going to need to take notes again in your composition notebook, as well as you're definitely going to need a calculator, so be ready with that. We're going to get some large numbers here. So why are we spending time doing this? Well, converting units is useful in life. Many of the things that you buy are basically publicized in a certain unit. There's unit prices. There's buying carpet, which is sold by the square foot or square yard. So converting units is going to be very important as a consumer, as well as unit conversions come up quite often in chemistry and physics courses. So changing units in acceleration or understanding gravity or working with these things called moles, as you'll learn later on in chemistry if you're in that course. So understanding how units are converted, especially complex conversions, will definitely help you out. Now, the converting part itself, you've done quite a bit with converting units, and oftentimes people can sort of get confused by what they're supposed to do. So what we're going to do is take a look at a different way to convert units, one that actually follows the unit itself. So let's think about what we understand about a simple number in math, the number 1. So what happens when you divide a number by itself? Like 3 divided by 3 or 3 over 3, as many times students would tell me in fraction form. Well, we all know that's the same thing as the number 1. We can see that. What if we take a unit and divide it by itself, like centimeters over centimeters? Well, again, that's the same thing over the same thing. So it would in fact be the same thing as 1. Understanding that units function the same way numbers do helps us out. Now what we're going to take a look at is a fancy form of 1. So a different way about thinking about the number 1, a different way to look at it. Think about this fraction, 1 foot divided by 12 inches. Is in fact that the same thing as the number 1? Well, 1 foot is the same thing as 12 inches. So it is the same thing divided by the same thing. So it would be equivalent to the number 1. It's just a fancy form of it. You see the 1, you see the 12, you may not be thinking 1 over 12 is the same thing as 1, but in fact it is, because we're taking a look at not just the numerical value, not just the numbers, but the actual value with respect to those units. 1 foot is the same thing as 12 inches. So this fancy form of 1 plays a special role in what's called unit analysis. Sometimes in chemistry or physics classes you may hear it called dimensional analysis. I would definitely write this part in my notes if you have your notes handy. Uses a conversion factor, this fancy form of 1, and units to help us see the steps we need to perform the conversion correctly. Okay? We think about canceling or dividing the units to help us. What our work is going to look like is going to look sort of like this. So this is a general example. Many times you may be asked to convert something like inches to centimeters. Now instead of just saying, well, I would multiply or divide by something, we take a look at a different sort of setup where we start with the 6.25 inches and we actually multiply it by a fraction. That's right, a fraction. And this fraction is a fancy form of 1. And understanding how units in fact sort of cancel or simplify away would help us figure out what we're going to do. Do we multiply or do we divide? So see how this problem looks? They started with the 6.25 inches, multiplied it by this fraction, this fancy form of 1. 2.54 centimeters is in fact the same thing as 1.0 inches. And by seeing how the inches on the top would simplify with inches in the denominator, so numerator and denominator simplify those inches away, leaving us with centimeters for our answer. This is the sort of setup I'll be using. This is called dimensional analysis or unit analysis to help us convert units. Okay, let's look at a few examples. This one's a pretty simple example, but again, illustrates what we're going to be doing. A European recipe calls for 5 pints of water. How many cups should you use? Okay, to do this conversion, we need to know a basic fact. We need to know that there are 2 cups in 1 pint. Okay, now it's more than just saying, well, do I multiply by 2 or do I divide by 2? Yes, this is a one-step conversion, but the conversions we do later are going to be multi-step and way more complicated. So let's set up this easy example in the way where we can follow the units and use this sort of analysis process to figure out what our answer is. So when you start with what you're given. So we are given that we have 5 pints of water. I'm going to write that first, 5 pints. And I'm going to make this a fraction, 5 pints over 1. And then I'm going to multiply this fraction by a fancy form of 1. So it doesn't change the value of the fraction, but it might change the units. This fancy form of 1 that goes right here has to be a true fact. So our fact that 2 cups is equivalent to 1 pint will go in this fraction. Now to write this, or to think about where we would write this, I was given something in pints. Pints is in the numerator, so I'm going to put pint in the denominator. And I'm going to write this true fact that 2 cups is the same thing as 1 pint as a fancy form of 1. 2 cups is equivalent to 1 pint, so it's the same thing over the same thing. Therefore, we're multiplying by 1. But what happens, because pints in the numerator and the denominator, they simplify away. And what we have left is cups. This is what our answer was asking us to find, or what the question was asking us to find for our answer. How many cups should we use? So now I just do what the problem says. I take 5 over 1, this fraction, times this fraction. Now to multiply fractions, you just multiply across the numerator, multiply across the denominator. 5 times 2 is 10. I have 10 cups over 1. 1 times 1 makes 1. So I have 10 cups for my final answer. Okay, again, you may have looked at this and said, well, I can do it way easier. I'm not asking for the easy way, because our problems are going to get a bit more complicated, and this way helps students keep track of what they're doing and understand that their answer is correct. Okay, let's look at a multi-step conversion. Let's say you're 16 years old. How many seconds have passed since you were born? Using the same setup, we're going to start with the fact that you're 16 years old. Okay, I'm just going to make this into a fraction since we're going to be multiplying by fractions, and it makes it easier to do so when you have all fractions. Now we're going to take this and multiply it by a fancy form of 1. Now, I'm looking to turn years that I was given into seconds, but I can't really do that in just one step. There's a lot to think about there. So let's start with the fact that we were given years. What's a fact that we know about years? Well, we know there are 365 days in 1 year. That's a fact. I'm going to write that as a fancy form of 1, a fraction. Now I'm going to put years on the bottom because, again, I have years in the numerator to start, and I want that to cancel out or simplify away because I want my end answer to just have seconds in it. So I'm going to write the fact that there are 365 days in 1 year. That is a fancy form of 1. Okay, by doing so, numerator, denominator units simplify away, and I'm now left with the only units I see are days. Is there another fact we know about days? I'll put this in the denominator since days are in the numerator here. Okay, well, 1 day is equivalent to 24 hours. Okay, so now the unit days will simplify away, and I'm left with hours. Is there a fact that I know about hours that might help me get to seconds? Well, I know that 1 hour, and again, I'm putting that in the denominator so that it'll simplify away with the hours that are in the numerator. 1 hour is equivalent to 60 minutes. Now I have minutes. Well, I'm almost to seconds. I know that 1 minute is equivalent to 60 seconds. Okay, so what I see is that all of my units have simplified away except seconds, and this is good because that's what I wanted my answer to have. And now, while this looks pretty complicated, we just follow what the math tells us to do. We're going to multiply all these fractions, and by doing so, or in doing so, we're going to multiply all the numerators, those are all the numbers on the top, and figure out what that number is, and then we're going to multiply all the numbers on the bottom and figure out what that number is, so we can find our final answer. If I multiply 16 times 365 times 24 times 60 times 60, I get the answer 504,576,000. Now, in the denominator, if I take 1 times 1 times 1 times 1 times 1, well, that's just 1. So in essence, our answer is 504,576,000. And units, again, seconds. So if you're 16 years old, that's how many seconds have passed since you were born. Okay, let's try a 2-unit conversion. This is similar to something you might see in chemistry or in physics. Let's say we're driving 45 miles per hour. What is our speed in feet per second? So to start this problem, we're going to start with what we're given. We're given that we're going 45 miles per hour. That means that we have 1 hour in the denominator of our fraction. 45 miles over 1 hour. Okay, this is the way our problem starts, and we need to start converting this into feet per second. Now let's just do 1 unit at a time. Let's start with feet. The units that I'm given talk about miles. I need to convert that into feet. There's a fact about feet and miles. There are 5,280 feet in 1 mile. So I'm going to use that fact and again write a fancy form of 1, a fraction using that unit knowledge, and I'm going to set up my fraction so that units will simplify away. I'm given miles, I want to convert that into feet, so I want the miles to simplify away. So my fraction will have miles in the denominator. So I'll have 1 mile on the bottom, 5,280 feet. And now these miles will simplify away. And now I do have feet as my units. So I'm done converting to feet. Now let's talk about seconds. The problem was given to me in hours. Now I need to convert that to seconds. Well, let's start with converting hours into minutes. There's a fact about hours. 1 hour is the same thing as 60 minutes. Okay, now notice that fact needs to be written as a fraction. Hours are currently in the denominator. I need to then write them in the numerator so that they can simplify away. So my fact was 1 hour is the same thing as 60 minutes. Now my hours can simplify away and I'm left with minutes. Now I need to convert that into seconds. Well, 1 minute is the same thing as 60 seconds. Notice how I put minutes in the numerator so that it would cancel with the minutes that are in the denominator. And you can see now I have seconds left. So I had the feet and now I have the seconds, and now I just do what the math tells me to do. Multiplying all the numerators, 45 times 5,280 times 1 times 1, 237,600. And then if I multiply 1 times 1 times 60 times 60, I get 3,600. And now if I divide those two things, my answer is 66. And make sure the units are there. That is 66 feet per second. Okay, one more like this where we have 2 units to think about. A pump can pump water out of a sump hole at 3 gallons per second. How many gallons per hour? Let's go ahead and start this with a setup of what we're given. I have 3 gallons per second, so 1 second is on the bottom. We need to convert it into gallons per hour. The problem is asking us for gallons per hour. Well, we already have gallons given to us, so we don't actually have to do anything there. The only thing we need to change is the fact that we have seconds here, and I would like to turn that to hours. So let's start with facts about seconds. Well, there are 60 seconds in 1 minute. So let's start there. I'm going to put the seconds in the numerator so that they will simplify. 60 seconds, 1 minute. Okay, now I have minutes as my unit. Let's talk about a fact that we know about minutes. Well, there are 60 minutes in 1 hour. 60 minutes, 1 hour. My minutes will simplify away, and I'm left with the gallons that I started with and hours as we created, and that's what the problem wants us to find, gallons per hour. So we want gallons in the numerator, hours in the denominator, and we have that. So now we just do what the math tells us to do. 3 times 60 times 60, 10,800. 1 times 1 times 1 is just going to be 1. So my answer is going to be 10,800 gallons per hour. Here are some equivalent units you may want to write in your notes as you're working with some of these conversions. Okay, take a few minutes and write that down, and then be ready to do some unit conversions when I see you next time. Thank you.